Ladies and gentlemen, now from mega projects to integrating project delivery, particularly in the construction industry, may I call upon Mr. Manish Shangari, Chief Executive, Think BIM. Right. Could I have the profile of Mr. Manish Shangari, please? Welcome on the dais, sir. Mr. Shangari.
Thank you.
Right. Mr. Shangari, as you can see, is obviously an IIT alumnus. All the stalwarts come from these wonderful premium institutes, and he actually propagates and enthuses people into green, efficient, and high-quality solutions so that, the technology is integrated into the project delivery model, both for project and program management. Now, to enlighten us how he does that and share the wonderful experiences, we have Mr. Shangari here.
Thank you.
Welcome, sir.
Can I have a marker?
Sir, I missed you.
I have this. I want to.
All right.
Yes.
Thank you.
Hello, can everybody hear me? Am I loud and clear? So, a very good afternoon to ladies and gentlemen. I know I'm standing between your lunch, so I would rather not take a lot of time. I've been given 40 minutes. I'll do my presentation in 3 steps. One, we'll quickly go through a presentation which we compiled. Then there are a couple of videos. And in the end, we'll have a question-answer session. If we have time, then we can go back to the presentation. So I was supposed to present this with my partner, Barry Warmore, who incidentally had an accident, so he's not here. So we work together in the firm called Think BIM. So today we're going to talk about project management the cutting-edge project management in the construction industry. What you see on this image is just not a 3D image. It's actually a whole lot of information embedded in a system which you can interact with. And this is the background of the entire model we work upon on all the projects. Can we shift to the next page? Okay.
For the slide changes, you need to move
this way? Okay, thank you. How do you change the slide? So this one? This one, yeah? Doesn't work. Yeah, thank you. I think the reason we found this company ThinkBIM is that we believe there's a time for change. The time for change is around construction industry. As we see in the last 5-6 decades, every industry has gone through a transformation, and there's been a significant performance improvement in the industry. But you look at the data coming out of US, the construction industry shows 40 to 50%, 30 to 40% wastage happening there, and the study shows 40 to 50% construction in US is behind the schedule. So you pick up every project, you plan a schedule, and 50% of chances you will run over the schedule, and there are about 30 to 40% of wastage in terms of material, labor, and time. So the whole idea is how to manage this time, cost, and enhance the quality using a process called integrated project delivery, which is based on a technology called building information management. Some statistics, UK construction industry 2025 strategy. This strategy is one of the most advanced strategy in the world, which aims to improve the construction industry. It is setting following standards: lower the cost of construction by 30%, deliver projects faster by 50%, and lower emissions by 50%. This is possible only by deploying a framework where you can manage all the stakeholders in a project in a central information system, which could be positioned in a cloud, where everybody can extract the information at the same time and everybody has the single source of truth. This has been done there with the level 2 BIM plan, which is the level ahead of what we are doing in India. And this is something we are going to adopt in India in various projects we are doing to work upon bringing in efficiencies in project management. I'll explain what exactly is BIM and IPD in the coming slides. Also looking at a bigger picture, a typical project cost, if you look at the way currently people have been working, are all the efforts in the current scenario are focused on reducing this initial 3% cost. A typical project cost is split into its initial design, build, operate, dispose phases, and where most of our efforts are around reduction of this 3% cost in the beginning. How to save few rupees or few dollars in the early stage of construction, which we don't at times understand can have an impact on the 25 years of a typical life cycle of a project, which can have 40 to 30% of impact in the project cost. So with this integrated project delivery, the management approach to the project is holistic. We don't look at the initial CapEx expenditure, we look at the OpEx expenditure. So for some decisions you would do in an early stage have an impact on the total life cycle of the project, which eventually would give you returns much better. This graph is an interesting one. This is the McCloy graph, which primarily what it explains is, on any project life cycle, the horizontal is a time dimension. As you move ahead in the project with the different stages from concept to detailed design, to construction, to commissioning, and then to maintenance, this curve, number 2, shows that the cost of any change of design, as you go ahead in the time in the project, changes immensely. And your ability, this curve number 1, the ability to impact the cost in the project, the ability which you will have to bring in to impact the cost, reduces significantly as the project goes ahead. So typically in the current scenario, the way construction industry works, we reach somewhere here where the traditional design process, this number 3, peaks up in the middle of stage, and then the changes happen at this stage, which causes huge cost implications down the line. With the preferred design approach, the integrated design approach, or the integrated project delivery approach, this graph number 4, we try to bring the stakeholders at an early stage, everybody at this stage. By bringing all the stakeholders at early stage, the decisions and the information which is needed to make the decision is brought early here. How this is possible? How this was not possible earlier is because of this model of integrated project delivery, which I'll explain down the line. What makes us possible now to bring all this information at an early stage and interact? The main reason is so very quickly, just to give you a brief background, before we get into the model of delivery, IPD is the integrated project delivery process which we deploy on these current new project delivery approach methods based on the technology which is called building information management technology. So building information management technology is nothing but putting the information of the entire asset into a model which runs on a various process streamlines, which integrates into an integrated project delivery methodology. This information model lies in a cloud environment, and every stakeholder can take information out of it at any point of time. To explain this further, I'll explain through this graph. If you look carefully, I don't know, some of the terms may look very technical, so I'll try to become a little bit more generic about it. This is the traditional way of working for any project in India or any project anywhere until now. We typically would do a feasibility, we'll develop some options, we'll try to get the investment ready, we'll design and engineer the project, do a constructability and construction on site, finally do the assembly, do the commissioning, and then finally let the project go on and decommission if required. This is a typical linear process, which means at any point of time, if I change my decision, for example, while moving, having to invest, at the time of design and engineering, if I decide, no, I don't want this plant or this railway system or this building to go in this way, but other way around, I'll have to go back to feasibility, assess the option again develop the options, again invest into it, and this creates a lot of time gap. So every time you go back into the system, it's a linear process. You waste a lot of time. You have to compensate for that. The IPD, Integrated Project Delivery, runs around a model which is a pulsating bubble model. If you look carefully, in this model, what is happening, the central core is nothing but a model which is a 3D model having all the information of every single element which an asset would have. To explain you simply, for example, if this hotel was to be designed and project managed, every single element right from the chair you are sitting in, to the columns, to the beams, to ducts, to HVAC chair, chiller, would be modeled in 3D with the specifications, with the performance specs loaded onto it. So at any point of time, you can then publish from the central file information across and do an analysis. For example, from this central file, I can do a quick analysis and see what kind of temperature and comfort conditions are coming into this building if I design it in this manner. Parallelly, what kind of analysis happens in the structural side of the building, how much I can reduce the concrete on the building. So this happens parallelly with various softwares interacting with this core information model. Any change which happens at any point of time goes back to the central file, and that's what we call as single source of truth. So at any point of time in project, this central file or the central information remains intact. There will be many different shareholders around it, but everybody comes back to the same file. From the same information, we can extract accurate build BOQs. We can link it to a Primavera or any other time schedule software and link it in a way that any time you change the schedule, it will show what the project movement would be and parallelly show what kind of cost impacts would come around that. So I'll show there are a couple of videos around that later down the line, that once you tie this entire thing up, you would want to see 6 months down the line, how is my project? It shows 6 months down the line, this much part of the project is made, X amount of money would be spent, Y amount of labor would be on site, this much material would be on site. So that helps you make decisions and deploy the process. Now, the same information file keeps becoming richer. You would imagine that having such a complex cloud-based file is not easy. So as the project goes, the information enriches on the file. As people come in, they keep enriching the file information. This information then eventually is used at the time of commissioning as well. You can then, even before commissioning a project, do a virtual commissioning by doing a full virtual analysis of the plant or the building or an asset. And eventually, finally, the same information is fed to a facility management software, linked to any of your facility management software, where you would get in a very user-friendly dashboard environment the entire asset. So you can go and, for example, click on a pump. It just drops down the entire specification of pump, vendor, date of installation, service date, and when is the next thing to be done. You click, it links to your facility management system and gives you a monthly cost of operation and maintenance. So this is the way you can actually integrate your whole project using the same information system. These slides I'll quickly go through. These are the slides which actually explain how this file develops its detail as we go forward into the project. So these are defined by some standards in the world which are called like LOD 100, LOD 200. So for example, when the project is in an early stage, we might have a very early massing level kind of a information file. As we go ahead, we could have a level 200 model where there'll be certain elements which will not be detailed enough. For example, reinforcement won't be there, cables won't be there, but main beam elements, main room elements would come in, which you can analyze. Similarly, going forward, the model becomes richer and it gets to a 300 level where you actually start putting the components which would be used in the building. And you take it to a 400 level where every single reinforcement, cable, wire, equipment is brought from the internet and put into the model. Over the last 10 years, 15 years, world has moved ahead. So any product you want to use in your project right now is available on internet in a modeled form. Most of the manufacturers in the West are now mandated to give their product. For example, if I want to install this projector assembly, it will be available online. You just bring it into the model, attach it to your model, and upload it into a cloud system. But these are done by these big companies who are actually promoting their own products. The small fabricators won't do it. And eventually the same model becomes a LOD 500 level where you can operate and maintain with that. Now, very quickly, go through some case studies of how this model information is used in saving time, cost, quality, and managing projects better. This is an example of a project which we did recently, where having the same FAR, same user requirement, same brief from the client, very quickly in our software we modeled it. We take this model to another software where we do energy analysis on it, and we take it to a cloud. It takes just about 25 seconds, and we get a comparative between all the three. So just if I may ask you, which of these three buildings, because all of these three are same FAR, same user requirement, would be the most energy efficient? Which would save you the most of the money? Can anybody tell that? So it's the middle one. If you do it on an online system, within 20 seconds, you get the report back of what kind of savings you get by deploying such even a change in shape. Because once you model this, it connects with the Google Earth. The Google Earth takes the information directly from the place where it is, and it gives you the saving which can be bought in terms of power consumption, the daylight which will increase, and the cooling capacity which you can increase better. So these are some of the very quick examples of using this building information modeling method to have cost control in the beginning of the project, which people don't realize when they go ahead. Similarly, we can do very accurate comparisons in the same model, and in one of the projects, we did a reduction of 180 kilowatt for a chiller unit, which is a huge amount of money, which you can do in a 3D simulated environment. The third advantage which you get out of this integrated project delivery approach is you can see virtually everything in 3D, so you can remove all the clashes, all the potential problems which will come on site. You typically go to a site, how it works. There's a tender package, people start the work, they go on site, and there are thousands of problems there. Things don't work, they don't connect to each other, the pipe would cross somewhere else. In this model, you can actually do a review, analyze, design, engineer, and remove all these things, and once it is done, you get detailed drawings out of it, which are to such an extent that the complete fabrication can be done off-site. You can do a full fabrication of building off-site in modules, and then bring it to site, reducing your time and cost significantly. We'll show you some examples on video as well. These are some data which shows the benefits of BIM already done in SIPC and UK research, where it clearly shows a typical project you can have a 20 to 30% of saving using this. I'll skip through these detailings. This is another example, for example, having a central file, there was a current design on the left. We did some minor changes on the optimized design on the right by just changing some facade elements, and you would have a reduction of about $1 per square meter of energy bill on top of it. Running for 25 years, it is a huge amount of money you can do. And this took us just about a day to do such kind of analysis using power of cloud and analytics, using the same energy model. This is another case study we did where we went from architecture level to a system level design, where we could analyze the pumps, the flows in the building, and could reduce about 22 crore worth in capital cost and about 300 crore in the operation cost of a hotel project. Similar case study for the hotel project, just by testing the conditions of temperature in the building, analyzing them in a virtual environment, finding out how the optimized final conditions will come in, saves us about 10 to 15% of money spent on the project and time as well. This is another example of a project where we saved about 48,000 meter of pipe lengths, because once we modeled the whole project in BIM, we could see from a holistic point of view how the distribution of these pipes are going around. And we could simplify everything. The way it is similar to how you design an integrated circuit board, the IC board. So once it is completely in front of you, you can start analyzing, you can start checking the performance of the building or the asset, and then optimize it. So we saved 30% on HVAC cost in this building, 12% on electrical cost, 40% of plumbing, 25% on fire, 5% on DG, and about 25% on lift. So these are the kind of cost savings which come purely because of the material you can save, and then on top of that, you have a control on time. Once this is done, we get it into a fabrication mode which improves your quality as well, which I'll show you. I'll skip through this. So as you see, this slide just explains how from a 3D model, which is done in a full BIM environment with all information loaded. By the way, this is just not a 3D information. There's a whole lot of information in this which can be analyzed. You can do a clash detection. You can do entire simulation. You can get accurate BOQs at any point of time. So, which is one of the biggest challenge for a project manager, to know what is the cost of project at any point of time. With this, at any point of time, you can, with a click of button, get almost 99.9% correct cost data, which helps you make decisions for change. Change is inevitable, but saying, for example, a client may say half project down the line, I want to change the size of this room from 100-seater to 50-seater. Changing at that point of time, what kind of cost impact will come in, immediately comes out in a minute, and somebody can take a decision, whether this change at this point of time is worth it or not. The same model then moves into a next phase